Welcome to this product presentation. I am David, an R&D engineer from Keysight Zurich. In this presentation, I'm going to show you how to use our multi-channel analog signal generator AP5012 to generate fast pulsed list sweeps. This multi-channel unit has the capability of running individual list sweeps on all of the 4 individual channels with a tight timing control. We can use this to generate sweeps that produce pulses with individually configurable timing. I use our versatile graphical user interface to control this instrument. This is a simple application that lets you control all of the features of this signal generator. I'm currently connected to the unit, RF is disabled, and the channel 1 is selected for configuration. As we run a list sweep, I will now enter the Sweep tab, open the List Sweep menu, and here I can upload a predefined sweep list to the device's playback memory. I can now do the same on channel 2. And upload a different list to channel 2. We can do this with all individual RF channels. Now, to enable synchronous operations on multiple channels, we use the trigger system. So we enter the Trigger Configuration tab and select the LAN trigger instead of the immediate trigger to later trigger all channels at the same time. I can now go back to the Sweep tab, enable the sweep, enable RF, do the same on channel 2, enable the sweep, enable RF, go to the Trigger tab. On the oscilloscope, we can now see that the RF outputs are still off. That is because both channels are now waiting for a trigger event. If I send the trigger event to the unit, the sweeps start immediately. I will now increase the time base on the oscilloscope in order to get a clear picture of our sweep. What we can see here now is that we get a sequence of double pulses. The higher power level double pulse is perfectly aligned between channels 1 and 2. The lower level second pulse has a timing offset of 200 microseconds. This shows that we can control the position of individual pulses with high precision. This is very helpful in applications like radar, where we need to produce pulse trains, but we also need to control the timing of each pulse individually per channel. In this setup, we also use individual frequencies per channel. We can now verify the timing of our pulse pair that uses a delay offset between the channels by zooming into the traces captured on the oscilloscope. I reduce our time base and shift the capture such that we see one aligned pulse pair and one offset pulse pair. We can now see that we get the precise pre-programmed 200 microseconds offset between the 2 channels. This feature is very important in applications like radar, where often multiple channels must be served with a stream of pulses, but different delays on different channels must be compensated. This list sweep feature of the AP5012 lets you compensate for individual path delays and lets you also compensate for individual pulse delays varying with the pulse number. Thank you for watching.